So our next speaker is here with us now, Michael Keller. Good afternoon, Michael.
Afternoon. Are you guys able to hear me?
We can hear you. Michael is a senior engineer at State Farm, managing high volume enterprise spatial data infrastructures and critical risk systems, and was a technical lead in building the State Farm geospatial platform as a service, which I assume will be a large part of what he's going to talk about. I'm really looking forward to hearing the story of PostGIS at State Farm and your adventures with it, Michael.
Sounds good. Thank you. Today I'm here to talk about specifically how State Farm uses PostGIS. So a little bit about myself. As Paul mentioned, I'm a senior technology engineer at State Farm within our enterprise technology department. I've been within State Farm and then within the geospatial field as well for a little over 10 years. At State Farm, I have built our internal geospatial platform as a service, and today I continue to help the team that maintains that platform as a service. That's completely powered by PostGIS in the background. So that's what I'm here to talk about today. So to give you guys a little bit of insights into what our platform is, it's called the State Farm Mapping Portal, or SFMP for short. It's the sole geographical platform that we use at State Farm, and it helps us take the ability to take either spatial data or non-spatial data, with the larger majority being non-spatial data, get that into our platform that allows us to do a multitude of different things, whether it's responding to a disaster, catastrophe, doing things like territory design for a multitude of different departments, and then things from like an underwriting perspective, doing risk assessments, and many, many more different ones that have continued to evolve over the years. So SFMP itself runs natively within AWS. That allows for us to have a highly scalable environment depending on time of day or specific analysis that people are looking to do to scale up and scale down infrastructure to help meet those needs. Faced with is we have all this great data and content within Postgres and PostGIS, but the big question is how do we actually make that easy and available for consumers to connect to? So most of our consumers at State Farm have no coding knowledge, no SQL, nothing whatsoever, but they have a lot of geospatial questions that they want to get answers to. So how can we make technology available for them to get those questions answered? So today I want to cover it from those two different lenses of one, how do we technically make all of this happen? And then two, what types of questions are we getting from our business partners and how are they able to do that within our platform? So here's a high-level architecture, extremely simplified down of how everything works within AWS. So on the left side, we kind of have that little computer monitor, which represents either our consumers, whether they're employees at State Farm, it's another application within State Farm, or it's some sort of non-human account connecting to our platform. So all of that is fed through a Route 53 record, which then gets passed on to an application load balancer within EC2, and then to a Fargate cluster, which holds a multitude of different APIs that kind of comprehend the entire platform itself. From there, we have Elasticache clusters and RDS Postgres clusters with PostGIS enabled to help answer that question of where. Majority of the time, we're hoping those API hits go to Elasticache, where we have a lot of those answers already stored and available just to get that quick response time from a better user experience perspective. But depending on what it is, or if it's a one-off type analysis, that will go off and go directly to our Postgres instances. This is more of a visual perspective so that you can see what does our whole platform look like. And what I did in this case as well is I drew a nice big box around what encompasses Postgres and PostGIS. So working our way from kind of bottom to top, first is we have all our different data connections. So we have a lot of different data at State Farm or that we get from different vendors or things like that for State Farm. So first off, we have a lot of different data within other AWS data warehouses. So we have ways to get that data ingested into Postgres. We're a very old company, so we have data still on the mainframe. So we got to get that into our more modern platforms in AWS. We have ways to get that and connect into Postgres as well. And then from there, working with things like Esri API endpoints, OGC WFS endpoints, or OGC feature endpoints. And then also your standard just HTTP stream. So thinking of things like the USGS earthquake. They just have an HTTP endpoint for GeoJSON data. We can go out, connect to that, and get that into our database. From there, we have a whole analytical suite built on top of all that data to help people start to analyze that data. Some of those are just using the native PostGIS functions, while other are more custom written UDFs in order to get the task complete as well. So things from like a suitability perspective, where is the best place to put an agent's office? Where can we start a new marketing campaign? Where's the most suitable area for that? Those are things that we can do from that suitability perspective. Enriching data, so if we get claims, which ones are near a wildfire or within a wildfire? Doing things like statistics of how many policies do we have in a certain geographical region, or what is the average coverage amount? How many claims happen with any specific area or event type? And then, of course, we can do things like impact and modeling. So what is the impact from a catastrophe, whether it's a hurricane, a hailstorm, a wildfire, whatever it may be. And then even future thinking of if certain types of events were to happen, modeling out and forecasting, how does that look? That can all be powered by PostGIS for us to help get those figured out. And then just your standard normal geospatial processing, clips, joins, buffers, convex hulls, whatever it may be. Those are all available for our users to use as well. Within our database itself, we have many different types of data. So your standard administrative boundaries, states, counties, zip codes, things like that. We also have more specific peril maps. So things like wildfire risk, hurricane risk, hail risk, things like that. We also have specific data sets to State Farm. So where are all of our agents? Where are our facilities? Our custom territories that we come up with, as well as where are our policies in force. And then with that, we have weather data that's coming in. So think things like USGS, so hurricanes, wildfires, all those types of different weather events. We ingest those into our database as well. And then we have just our standard users coming in and bringing in data as well, whether that is geospatial in format or non-geospatial in format, and we convert that into a geospatial table. So in order for all of this to work, we have a multitude of different APIs that connect to our Postgres database to make all of this happen. So our first one is our collections API, which for the most part has a lot of API endpoints related to the OGC features and tiles standards. And then on top of that, we have some more custom and specific ones to do things to help power our platform. So things like autocomplete, doing statistical analysis that are outside of that standard OGC realm. Then we also have our analysis API where they can go and plug and play with that whole analytical suite that I talked about below. We also have an imports API to let people bring data in, whether it's in a flat file format or something sitting out on a web page or something else within State Farm. They can point to that, press load, and it will bring that data in for them. And then we have an items API to basically search through this entire catalog of all these data sets and then kind of jumping up to above all these different maps and apps that are available for them to build out as well. So once we have all these APIs built up and established, this is where most of our user base is sitting on using our platform every single day, is the single page app that allows them to do things like we have a map builder that connects to all of these different APIs to allow them to query the data, analyze the data, color code it, visualize it, and then share with others throughout the enterprise. We also have a multitude of different no-code apps. It's all drag and drop interface where they can do things like build out graphs, build out analytical widgets, things like that to help them query and analyze the data and share that with others in the enterprise who may not have any geospatial background but can go into a dashboard and zoom in and out and get information that they need. We also have a portal search just due to the mass amounts of data sets that we have within the tool. This allows them to search on key contexts or filter by date ranges or types of data, whatever that may be. And then we also have a Python SDK built around all of this as well for our data scientists within State Farm so that they can do things thinking within like Jupyter notebooks so that they can query and analyze business data and then ingest that or analyze that from a geospatial perspective. So how do we make this kind of easy from a user experience perspective, and what does it look like on the back? So on the left here, this is kind of a screenshot that we have from our map build, calculating geometries, things like that. They go in and select one or two different buttons, configure that analysis, and click Run. That then sends that request off to our analysis API, which is running within our Fargate cluster. And what we do then is actually validate, hey, whatever analysis that they're running, do they actually have access to that data set? Not everybody has access to every data set, so we basically want to perform that easy validation. From there, we can generate that SQL query, pass that back onto the database, and then using whatever those specific functions are, we can go ahead and generate that new table from that analysis request. Once we have that table built then, we gather a bunch of metadata about that table. So who created it, who did they provide access to, how large is the table, and then continuing forward, kind of have an audit trail so that we can understand what that data is, when it was used, and retain it in case we need to as well. And then once that, kind of jumping back, once that analysis is complete, like everybody, we want to be able to see that data. So that's where we backtrack to our collections API. Our collections API allows us to visualize that data using our vector tile API endpoint. So this map is showing all of our State Farm agents throughout the entire US, and that just comes back as vector tiles. So how that works is same thing kind of like before. Because of all the different types of data that we have within our portal, and it's allowed to be used by anyone within our enterprise, we want to make sure, does that specific user should have access to that data set? If they do, then what we're going to do is actually check to see if that tile has been cached. So for anyone who's ever generated vector tiles on the fly within PostGIS, if you don't, no, depending on how complex that geometry is or how much geometry there is, it can take a very long time to get that tile generated. So what we do is if it's something that has been generated before, we go ahead and store that off in Elasticache. And then at that point, when they actually make that API request, we're just going to pull up the ZXY coordinate and that specific map, get the bytes for that, and return it back to the user. If not, that's okay. Then we can go ahead and generate that SQL query, send it off back into PostGIS, and at that point, using the SFMP function, generate the tile that's needed for that specific location and return that back to the user. And then in the background, we'll then actually take that byte array and push that back into Elasticache. So then either the next time that user goes to that specific viewpoint, or if they share that data set with somebody else, they're going to get that better user experience because we're going from potentially something that takes a couple of seconds to 50 to 70 milliseconds to get that data pulled back from the API and painted onto the map. So these are just a couple examples of, from a technical perspective, how can we take all these different data sets from either different external sources that we get or from internal data that we have at State Farm and make that available for consumption for users from within our platform. So now I want to switch into what types of questions are we answering with PostGIS at State Farm. So as you can imagine, insurance company, we have claims and a lot of them. So our claims department is one of the largest users of our platform as a service, and they use it on a daily basis to help our customers. So a couple of different examples of how are they using our platform is doing things like analyzing catastrophes. And that is for every type of catastrophe. So in this example image here, we have some satellite imagery with a wildfire perimeter. So if you could imagine, at this point, then we'd be able to overlay our policies and force to see, are there any policies directly within the perimeter? Are there any that are encroaching on that perimeter of the fire? This allows us to quickly look at that, and then we can also do it from an analytical perspective to say, model out if this fire continues to grow, what does that impact look like? And then as our claims start to come into our claim system, we're able to then kind of see in real time where those claims are. Are people reporting them? Are they not reporting them? To help us better understand what is the impact of that specific event. For larger events where thinking things like hurricanes, we can get 30, 40, 50,000 claims coming in. We have the ability to automatically assign claims as well, just due to how long it would take from a manual perspective to assign those claims. PostGIS helps in that perspective because, as you can imagine, when you have that many claims, it's going to be a lot of people that are going out and helping those people. So we want to make sure that that claims adjuster isn't bouncing around all over the place. So when we get those claims assigned, we can keep them locked in into a very small perspective of geospatial area so that they're not driving 10 miles to this house, 15 miles to this house. They're going to stay within a very small area. We also use PostGIS to help build our claims territories for non-catastrophe claims. Kind of from the same perspective, we want to make sure that we don't have too many claim handlers in one location where they're not getting enough claims coming in, or vice versa. One claim handler is trying to handle too many claims at once, and we want to make that a better experience. So it can go both ways there per se, and that can be based off, same thing is based off of their geography, as well as metrics within State Farm that we use to determine that. And also we use PostGIS to help route vehicles to the nearest repair shop. And that could be while they're still at the accident scene or already at home and they're going ahead and calling in and reporting that claim. We can help PostGIS to help decide what repair shops are there and which ones the customer wants to work with. So kind of a cool example that we had working kind of hand in hand with claims was in response to wildfires. So as our user base continued to grow of using our platform, claims started to use this on a kind of hourly basis when large wildfires were burning, where they were repeatedly doing the same analysis over and over again, where they actually came up with a whole process to say, these are the specific geospatial analyses that we want to do every time a wildfire was happening so that they have a consistent report to share out with others. The issue with this, though, is there was only 1 to 2, maybe 3 people within our area that could go ahead and run those reports. So what we did was work with them to figure out what are all those analyses that you guys need to run for every event. And we went ahead and built that as a new endpoint within our analysis API. At that point then, within our platform, they just had a drop down where they could simply just say, what was the name of the wildfire that you're interested in? Click Analyze. And then at that point, we always had a consistent report that would come out on the other side that would give them a bunch of GeoJSON data back so that they could look at that and get metrics about what was the impacts of that specific wildfire. So this was really cool to see because it was nice for those couple of people within claims. They kind of got that relief of, I don't have to keep doing this over and over again. And then it also gave the ability for other people within the department to be able to go ahead and respond to, from a geospatial perspective, to those events. We also use PostGIS a lot from an underwriting perspective. So PostGIS gives us the ability to look at every single property from a peril perspective. So anytime a new property comes in, we want to know, one, where is it located? And then from there, what are all the different associated risks for that property? So what's the risk of a hurricane, what's the risk of storm surge, whatever it may be. PostGIS has the ability to take that take that point and give us that information, which is great. And we can do that at an individual property basis, or we could do it at an entire book of business scale, or narrow it down to specific areas. That can all be done within the platform to help underwriters better understand that type of information. It also helps from a market penetration perspective, kind of the same concept of we have X amount of policies within this location. Do we have room to grow within that area? And then as well, they can kind of focus and move around within the map to specific areas and get regenerated and recalculated information on the fly so that they can help make their decisions. So these are just a couple of different examples from a business perspective as well of what type of questions do we get from our different departments and how we kind of tailored and built our platform around those. So that is all I have for today. Thank you to Elizabeth and Paul for giving me the opportunity to talk today. If you guys do have any questions, looks like I have a couple of minutes to answer. If not, feel free to get in touch by going to the URL below and filling out the form. Thank you.
Thank you, Michael. I really appreciate you coming to PostGIS Day and giving this presentation and letting us know what's going on at State Farm. So I see one question hiding in the in the chat, and it's a question I had actually, which was
Yeah.
when you decide to expire the Elastic Catch? um,
Good question. So it depends. So we have data that the location services team, which is the team that manages this platform, they have a bunch of data that they're responsible for that gets updated on different intervals. So in some cases for like live data, we actually don't even cache it whatsoever because it's being updated so frequently. We want to make sure that nobody ever even hits potentially a cached tile. It's always fetching directly from Postgres so that they get the most up-to-date data. In other cases, if it's data, so like states, the boundaries really never change for those. So those we just simply leave because a lot of people like to use those from a thematic perspective, and those can just directly get re-rendered. So really it depends on what the data set is. And then if it's user data sets, those have specific policies that we have to follow within our organization that have retention set on them. Those are just based off of those. Once it hits that retention policy, it just rolls off of Elasticache.
yeah. I have the de rigueur AI question because I mean, whether you like find the prospect of AI exciting or terrible, because I feel like you've done the hard part, like in assembling a whole bunch of consistent data and having metadata about it and standardizing your platform and APIs. Like it's not a moving target. Um, and it would seem like a place where you could get AI to be fairly reliable in terms of the answers it gave back. Have you started playing with that? Are you afraid to play with that? What's your posture on AI?
Yeah, good question. Don't have anything that I can say within this talk specifically right now, but it's definitely something that we're looking at internally.
And okay, I have another impolitic question, which is so you're in this realm of providing end user maps and cartographic visualization, and I found in organizations frequently the desktop wags the dog and
Mhm.
determines the platform you're allowed to build. Like, why hasn't Esri shut you down, or why didn't they shut you down when you started?
In terms of like building the platform.
Well, I mean, oftentimes I found like the Esri, if an organization has an existing Esri user base that has its
Mhm.
hands around the function, that will determine a lot about how you end up architecting the platform or the
Yeah.
central system.
Oh, I see. Yeah. Um, so in our case, we kind of got we previously had our own, prior to this tool, we had kind of our own internally built mapping product. But this
Oh,
was like in the early-ish 2000s.
yeah.
So it didn't have a lot of the functionality that you would see in any kind of platform as a service today, whether you build it internally or buy that from a vendor. So luckily, that's where kind of our core user base was at the time. And we were kind
Hmm.
of just able to lift and ship them onto this platform. And then from that point, we just continue to build and build upon it based off of whatever the requirements were.
for your apostates to start with. Um, what's coming next? What's your next big change to the platform?
Yeah. We're at a pretty good state where a lot of our business partners are kind of happy with what they're seeing today. So once we hear more from them, that's how we continue to adapt based off of that.
Awesome. Well, thank you very much for joining us, Michael.